Welcome to the Biomembrane Lab. We are a Biomembrane NMR Lab and, among the others, our research focuses on membrane proteins and membrane environments, antimicrobials, quorum sensing, high-performance computing, and interactions of hydrophilic organic molecules with membranes. In this series of short videos, we will show you various aspects and applications of solid-state magic angle spinning NMR and, of course, how to use it. It is not normally possible to obtain high-resolution spectra from solids, but magic angle spinning allows us to do exactly that. The recording of high-resolution spectra from solids requires sample rotation at high speeds at an angle of 54.7 degrees with respect to the external magnetic field. This is called the magic angle. In order to do MAS-NMR, the sample needs to be rotated at high speed about the magic angle, and to do this, we need to load the sample into a special rotor. So today, we will show you how to pack and unpack a solid-state rotor. The 4mm rotor is made of zirconium oxide and can spin up to 18 kHz. The rotor sleeve itself is complemented by a drive tip, a bottom sample spacer, a top cap and a tiny screw. Other accessories include a sample packer and depth indicator, a top cap extractor tool and an opening tool. To start assembling, insert the bottom spacer into the rotor sleeve. Insert the brown tip into the sleeve by rotating it with the aid of an opening tool until you can no longer see light passing through between the tip and the sleeve. If you struggle to insert the drive tip into the sleeve, you can also use liquid nitrogen to carefully dip the drive tip and the sleeve. The low temperature of the nitrogen will make the cap ever so slightly smaller so that it can fit inside the sleeve. Please be aware of the hazards associated with the handling of liquid nitrogen. If you're not a trained user, please seek assistance from someone who is properly trained. Then use the sample packer to push the bottom sample spacer down until it touches the drive cap. It is important for the bottom spacer to be right at the bottom of the rotor in order for the sample to spin properly. Now you're ready to load your sample. For membrane samples, which can be bacterial membranes or artificial membrane models such as liposomes, use a Gilson pipette to retrieve your sample. We recommend to cut the end of the tip off, especially for thicker or more viscous samples. This is to ensure they are nicely suspended and do not block the opening of the tip. Once your sample is in the tip, gently insert the tip into the top of the rotor sleeve. It may be useful to leave the tip into the rotor and briefly spin them down to ensure all the sample is removed from the tip and is into the rotor. This will also ensure the sample is at the bottom of the rotor. Make sure you cover the bottom of the Eppendorf with some tissue paper before inserting the rotor to prevent damage to the drive tip. After loading your sample, place the top cap into the sleeve and push it down until it is in line with the sleeve. Carefully screw the small screw onto the top spacer using a set of tweezers to prevent sample dehydration. Make sure you leave a portion of the screw out to be able to grip it with the tweezers to unscrew when you unpack the rotor. Before you insert the rotor into the NMR spectrometer, draw a black line covering approximately half of the rim using a black permanent marker. This will act as a laser mark and allow the spectrometer to correctly detect spinning. To unpack the rotor, unscrew the top screw using a set of tweezers. And screw the top cap extractor onto the top cap, where the screw used to be. Now pull the cap extractor until you remove the top cap. Use the opening tool to remove the drive tip by twisting it. Once again, it can help to use liquid nitrogen. Now insert the sample packer at the bottom of the rotor and push upwards. Your sample will come out from the top of the rotor before the bottom spacer. You can either discard your sample or collect it back into an Eppendorf for future experiments. To clean the components, immerse the rotor, the top cap and the bottom sample spacer into water if the sample is water soluble, or use some ethanol. Take them out and dry them using some tissue paper. Remember, you should never use any metal object to clean or handle the rotor, as they will scrape the rotor and therefore damage it.